Okay, we're going to be continuing our discussion on compound inequalities. Now, the other day we looked at the word and what that meant. Today our focus is going to be the or, and what does that mean for us? Okay, so when we're looking at this particular example right here, and I understand that that's not going to be the same for all the classes, but just to kind of give you an example, it says, I am driving to dinner, or sorry, I'm going to dinner and the movies. Now, when we talked about the word and, it meant it had to be true for both. And so if you recall, that's where it was overlapping because those numbers were true for both inequalities. What we're going to do today is we're going to take that word and out and we're going to stick the word or in its place. Okay? Now, when I stick the word or in there, I'm now changing the meaning. If you think about it, it says, I am going to dinner or the movies. Okay? And so that's saying only one part is true. So when we're looking at this, we're going to break it off here for you. Okay, one part. All right, we're going to be looking at this first example. And on this first example here, you see a plus 1 is less than 4, or a minus 1 is greater than or equal to 3. Now, an or statement will always have that or wrote in it. It's not like an and that will be scrunched together. So on an or statement, if you kind of look through here, all of these, you're going to see the word or in them. Okay? So we're going to go ahead and start solving this first equation by subtracting the 1 off both sides. So I get a is less than 3. And on this one, I'm going to add the 1 to both sides. And a is greater than or equal to 4. Again, we're going to be graphing just like we've been doing. And I've got a 3 and a 4. I have an open circle here shading on the outside. And I have a closed circle here shading on the outside in the other direction. Now, unlike an and statement, we're looking, in an and statement, we were looking for where they overlap, so nothing overlaps here. But on an or statement, we're looking for everything that's been shaded in, and that's our answer. So a typical or statement will show shading on the outside. Now, of course, that's not always going to be the case. There's always special exceptions to that. But on a typical or, you're going to see things kind of usually shaded on the outside. So again, everything that's been graphed is an answer. So this guy right here is not an answer. This is good, and this is good. All right, so now you do still have to write your final answer in set builder notation. So line A. Now the difference between an and an or is I'm just going to rewrite this with the word or in it. There's no scrunching in or. So it'll be A is less than 3 or A is greater than or equal to 4. And this is the answer that we're looking for. All right, let's go to the second example here. And I've got X is less than or equal to 9, or 2 plus 4x is less than 10. Now, it's nice on this guy here, there's no shading or no solving, so we don't have to worry about that. So I'll go over the other one here, and I'm going to start by subtracting 2. So I have 4x is less than 8, and dividing by 4. So x is less than 2. All right, and I'm going to go ahead and do my number line here. And I've got 2, 3, 4, 5, 6, 7, 8, 9. All right, and I'm going to go ahead and continue to do the x is less than or equal to 9 in blue. So I've got a closed circle, and I'm going to shade this way, because that's what way my arrow is pointing. Okay, and on the 2 here, I've got an open circle shading this way. Now, on an and, we would be just looking right here. Where do they overlap? But because it's an or and we're looking for everything that's been graphed, everything from here over has been graphed. So that's going to be my answer. So my answer is actually going to cut off right here, and it's going to include everything this way. So now when I do my final graph, because that's just kind of a working graph in this case, I've got 9, 8, 10. I'm going to have a closed circle on 9, and everything in this direction is shaded in, and that includes the 2. That's why we don't have to put this 2 right here, is because it's included, implied when we shade everything off to the left side here. So again, you're going to go ahead and do your set builder notation, line x line, and now because we're only using the 9 in our final graph, that's all that's going to be in our final answer. So this will be our final solution. Again, the 2 is covered up by that 9, so we don't have to worry about it. All right, let's go down here to the third example. And on this example, we're going to start by dividing this one by 2 on both sides. So x will be less than -8. And on this guy, I'm going to multiply both sides by -2. Now, we're still struggling a little bit. you have to understand that you multiply by negative 2, these cancel. You have x minus 4 left. I still have a lot of people that are trying to distribute that negative 2 through to the top part there, and you can't do that. This is saying 2 over 1, the 2's cancel. Less than, oh, you know what? I forgot to change my sign, didn't I? Anytime I multiply or divide by a negative, I need to flip my inequality sign, so it actually becomes greater than negative 14. Now I'm going to add 4 to both sides, and x is greater than negative 10. All right, so I'm going to get my graph going here. Negative 10, negative 9, negative 8. Okay, I'm going to start by graphing the blue one here. So I've got an open circle at negative 8, and I'm shading in this direction. Okay, on the 10, I've got an open circle on 10, and I'm going to shade in this direction. Now, with that being said, when I'm looking at my graph here, again, I'm looking for everything that's been shaded. I'm not looking at and where they overlap. That's not what I'm looking for right now. I'm looking for everything that's been shaded. And if I look at this number line, everything's filled in here, and then everything's filled in here. So if I drop that red line down, actually onto the graph, I shade this way, the entire number line is shaded. So when that entire number line is shaded, it's going to be all reals. That's what we're looking for. Okay. All right, let's take a look here at one more of these. I'm going to start by solving again. So I'm going to start by adding the 6 to both sides. So I've got 3x is greater than or equal to 9. Divide by 3. X is greater than or equal to 3. Again, there you see that word or, because we have to write the word or in there, otherwise it's an and statement. And then I'm going to add the 4 to both sides. So I've got 3x is less than negative 3. Divide by 3. So x is less than negative 1. Okay, let's start my graph. So negative 1, 0, 1, 2, 3. Okay, and I'm going to go ahead and do my red here first. I've got a closed circle on 3, and I'm shading out. Okay, on the negative 1, I have an open circle, and I'm shading out. Oh, still shading out here. Okay, so now again, what's been graphed? Everything here's been graphed, and everything's over here has been graphed. Nothing in the middle. Okay, so in this case, this is just that typical OR that we were looking for that we talked about a couple examples ago. And so my final answer, set bracket, X line, and I'm just again going to write this guy and this guy with the OR in between. So I'm going to have X is greater than or equal to 3, or X is less than negative 1. Okay. Again, you do need to take note. It would be the same thing. If I say x is less than negative 1 or x is greater than or equal to 3, so where you can see where I've kind of flip-flopped them, that's okay. It's the same thing. And so this right here will be my final solution. All right. Now let's take a look at what happens on an OR graph, and this is just going to be us practicing writing our final answer. Okay. Again, an OR statement is always going to have an OR in it. So I'm going to start with set bracket, any variable you want. So I'm just going to use x. And I'm going to start with this guy right here. And since I've got an open circle at negative 2 shading out, that's going to be x is less than negative 2. You have to include the or in the middle. And then I'm going to look at the second part here, and I'm going to close circle on 1, so I need that equal sign shading out to the right on this side. So I'm going to have x is greater than or equal to 1. Okay. All right, let's try it again here. So I've got set bracket, x line. In this case, I'm at negative 1, shading out. So I've got x is less than negative 1, or x is greater than 2. Okay. All right, and let's go to the third page now. All right, so now we're going to take a look at a problem where it says define a variable, write an inequality, solve. And remember, this includes graphing. It's right here in our notes. I know some of us struggled with that the other day, okay, because we didn't get to quite finish this problem. So I'm going to start here. I'm going to zoom in here. The sum of a number and 3 is no more than 8, or it is more than 12, okay? All right, so first thing we're going to do, x equals a number. Okay, we'll start breaking down our words. So it says the sum of a number, which means addition, and 3 is no more than 8. So that means 8 would be my biggest number. So I've got x plus 3, got 8 on the other side. No more than 8 means alligator mouth has to eat that 8 because 8's the bigger number. Now here you're going to see we've got an or statement right here in the middle. So we've got or, okay, and then more than 12. Again, we're going to replace the ending and put this guy in its position. So we're going to have x plus 3 greater than 12. All right, and so now it's just a matter of solving. Subtract the 3 off. So x is less than or equal to 5. On the other one here, we're going to subtract 3 again. And I'm going to x is greater than 9. So again, we graph because that's part of what we do now every time. So 5, 6, 7, 8, 9. Okay, I have a closed circle on 5 heading out. I've got an open circle on 9 heading out. So that looks like a pretty good or statement to me. So I'm going to go ahead and write my final answer. So x line, x is less than or equal to 5, or, again, don't scrunch it, it has to have the or in it, x is greater than 9. And that concludes the or part of lesson 5-4.